Hi everyone. So today's lecture will be really short. We will learn more about regression and how to re-express data. Given that the regression is a linear model, bends is always a problem. But bends is often not apparent in the scatter plot of raw data, and therefore residual plots will help. So this shows the data that the relationship between dive heart rate and duration. And the bend was not apparent in this raw data, but if we draw the residuals using the regression line, the bend becomes apparent. And sometimes there could be some subgroups and it's not apparent in raw data, and in that case look at the histogram of the residual and you will see some subgroups, and if we draw the residual plot you can find some outliers. If you already know there are different groups, you can get the regression line separately for each group. And extrapolation is not always warranted because there could be some sampling bias and generalization error. So be careful when you want to generalize your model in the area that you don't have the data. And as we learned about correlation, the regression doesn't tell us about causation. And outliers, we really need to be careful about outliers in the linear model. So there is a quote from Archimedes: "Give me a place to stand and I will move the earth." It's about the leverage. And in the regression model, if the outlier located near the center of math line does not move that much, however, but the outlier drops R² a lot, so the model fit becomes really bad. But the outlier is really far from the group, that becomes really heavy, so that the regression line changes a lot, and that could increase R² a lot. But in fact, the model is not really good, just R² increased because of this one outlier. So we need to always check if there is an outlier in the linear model. And we talked about lurking variable before, and it's still important to consider. And always be cautious in working with summary statistics. It's always important to see the data with bare eyes. Given that we are building a linear model, what happens if the data don't show the linear relationship? In that case, we can use re-expressing data with many different ways to make the data more linear. So this shows the shapes. If your data has this shape or this shape, this shape, this shape, like this, to see this, you have to visualize your data first using scatter plot, right? And if your data look like this, you can go up on the ladder, Tukey's ladder. So this is the reference point, and then go up means you can increase the power. If your data shows like this, you can go up. That means you can take y² or x². Okay, square or x to the 3, y to the 3. If your data has this shape, you can go down on the Tukey's ladder for x. Go down means you can take square root of the x or logarithm of the x, or you can go further like that, but usually 0 level, 0 power works quite well. So logarithm is quite good way to re-express your data. So for example, log x and y, you can use these values. And if your data has this shape, you can take log for x and y. And also, you can try the square root of x and y. If your data has this shape, you can increase x and decrease y, like log. Okay, so you have to know which shape your data have, and then go up or go down on the Tukey's ladder. So I said that this is a reference point, this is raw data, home base, and then you can go up or go down. Given that we use logarithms a lot of times, I have made a separate slide for logarithms. And we can use logarithms when none of the data values is 0 or negative. The data shaped like this, you can decrease the y here like this. And if the data had this shape, you can decrease the x, go down for the x, and use y. And if the data show this shape, you can use this and this. So watch out for negative data values, because we cannot use a negative value for log. So one possible cure for zeros and small negative values is to add a constant. And also watch for data far from 1. If all the data are far from 1, logarithms may not do much for those values. So consider subtracting a constant to bring them back near 1. For example, if you are dealing with years, you can subtract 1999 from 2000 and then make it 1. Okay, so this is all for today. This was short, and don't forget the quiz. You can find the link in the note. Thanks. See you in the class.